that we can pass out if need be. Okay, so for the next lesson, 1.4, this is dealing with absolute value expressions and equations. So these expressions and equations were part of Algebra 1, but I do know that after learning this and after seeing it, students still tend to ignore absolute value bars often, so just make sure you're not doing that, and as we go through this, if you have questions, let me know. But the first goal we're going to look at is being able to evaluate an expression that has absolute value in it, so just reviewing that, working with absolute value. And I first then want to review what absolute value is. So can somebody just define what the absolute value of a number is? When we're talking about absolute value, what are we talking about?
The value away from zero.
Yes. Yes. And rather than saying the value, I would say the distance away from zero. So the absolute value of a number is the distance. I'll say the distance it is from zero. And what are some things we know about absolute value, or one big thing we know about absolute value, Trenton? So it's always positive. I'm going to put on here, though, it's always positive, or it could be zero. But like Trenton said, it just can't be negative. So since zero isn't positive or negative, that's why I include it's positive or zero, because it could be zero. And then just if you want to include on here, we have talked about the notation or the symbol for absolute value. We talked about it the first day as a grouping symbol. So the absolute value bars. And that could be the absolute value of a variable, a number, an expression, but those bars mean absolute value. So I'm just going to write a few examples just to kind of refresh our memory. So absolute value of 4 is 4. Absolute value of negative 4 is 4. Absolute value of 0 is 0. Okay, so you could have a positive value inside the absolute value bars, in which case its absolute value is equal to itself. If inside the absolute value bars it's negative, that distance from 0 is still positive, so it's a positive 4. And then if you get 0 inside of an absolute value expression, that absolute value is 0. So then I have below here, and again, we talked about this the first day. We talked about it as a grouping symbol. So absolute value bars, like parentheses or like brackets, they're a grouping symbol. So when you're following order of operations with an expression, you should follow order of operations inside of those absolute value bars first, and then get that down to one number before you're actually taking the absolute value. So we have two expressions. We're going to look at the first one together. So 8.4 minus the absolute value of 2n plus 5. Evaluate that if n is negative 7.5. So we know with expressions, we substitute the values of the variables in first. So 8.4 minus the absolute value of 2 times negative 7.5 plus 5. And then we need to simplify inside of those absolute value bars first. And make sure that until you actually take the absolute value, that you're not dropping those absolute value bars and just losing them. So I'm going to keep the 8.4 minus absolute value bar. Inside we need to multiply first. 2 times negative 7.5 is negative 15. We still have the plus 5. And then we need to add inside of the absolute value bars. Negative 15 plus 5 is negative 10. We still have the absolute value bars. We did not take the absolute value yet. So now in this step, we actually take the absolute value of this number once you get one number inside of there. The absolute value of negative 10 is positive 10. So this becomes 8.4 minus positive 10. Or just 8.4 minus 10, so it's negative 1.6. So also be careful in that second to last step you can't distribute inside of an absolute value bar. So these two negatives here do not change to become a positive. If you did change it that way, you would get a different answer, which wouldn't be correct. So make sure that you're taking that absolute value first before you're applying any symbol outside of it. Questions on example 1? All right, I'm going to have you do